Welcome to Study Loop.
If f is an even function, then we know that opposite x values have the same y value, so f of x equals f of the opposite of x. If g is even, then opposite x values have the same y value, so we know that g of x equals g of the opposite of x. So then what would f plus g be? F of x plus g of x. Well, we could replace f of x with f of the opposite of x since they're equal. And then we could replace g of x with g of the opposite of x since they're equal. And so now we know that f of x plus g of x is equal to f of the opposite of x plus g of the opposite of x, which means that f plus g is also even. What if f is odd and g is odd? What about f plus g? So if f is odd, then f of the opposite of x will equal the opposite of f of x. We could also say that the opposite of f of the opposite of x equals f of x. That's a mouthful. If g is odd, same thing. G of the opposite of x is equal to the opposite of g of x. If we multiply both sides by -1, the opposite of g of the opposite of x is equal to g of x. So what about f plus g? F of x plus g of x could be replaced with, we could replace f of x with the opposite of f of the opposite of x. And then we could replace g of x with the opposite of g of the opposite of x. And this, if we want to factor out the negative, we get the opposite of f of the opposite of x plus g of the opposite of x. So comparing this line and this line, we see that f plus g is odd. All right, so what if one of them is even and one of them is odd? If f is even, then f of x equals f of the opposite of x. If g is odd, then g of x equals the opposite of g of the opposite of x. So what about f plus g? F of x plus g of x. We could replace our f of x with f of the opposite of x. We could replace our g of x with the opposite of g of the opposite of x. So we have f of the opposite of x minus g of the opposite of x. That does not look equivalent to the original. That does not look like the opposite of the original. So it's neither odd nor even.